Hi everybody, so this is the video for Objective 1 for Unit 7, which is algebraic factorization. So this video is going to be all about common factors. So common factors is a topic that we have seen before, you have certainly seen before. We've done it in the past, mostly we have done it with whole numbers. So we're moving into a new unit on algebraic factorization. So if you recall, algebra means math with letters. So the factoring that we're going to be doing today is involves algebraic terms, so letters and numbers. So we're going to look at a few examples here just to kind of wrap our heads around what this is all about. So the first example that I have here is 12 and 18. So this would have been an example of something that we've done in the past, that you've done in the past certainly. So there are many ways of determining the highest common factor of a set of numbers. I am not so concerned about how you arrive at the highest common factor. I'm most concerned that you can arrive at the highest common factor. So I'm going to show you one method. It's very possible that you've learned a different method, and it's fine for you to go ahead and do that. So the way that I would approach this question is I would look to list all the factors of 12, list all the factors of 18, and then just pick from both lists the highest one that they share. So I would kind of go over and do a 12 over here, and I would tackle them in order to make sure that I didn't miss any. So I would do factors of 12, 1 and 12, 2 and 6, 3 and 4, and then the next one I would try to do is 4, which is already on the other side of the list, so I'm done. So then I would go back over here and list them out in order, 6, 12, and then I would do exactly the same thing for 18. So we've got 1 and 18, 2 and 9, 3 and 6, 4 doesn't work, 5 doesn't work, and then 6 is already in that list, so that I'm done with that list. 1, 2, 3, 6, 9, 18, and then I would just have a look at both lists, and I would see, okay, 1 is in both lists, 2 is in both lists, 3 is in both lists, 6 is in both lists, and that's the largest one that appears in both lists. So therefore, the HCF or the GCF, whichever you prefer, of 12 and 18 is going to be 6. So this is not new. You've done this before. But what we're going to get to today is what do we do when we have algebraic terms and we're asked to find the highest common factor of an algebraic term. So there's two components. There's the numerical component, the coefficient on the term, and then there's the sort of the alphabetical or the variable components. So you need to identify the highest common factor numerically and the highest common factor sort of alphabetically. So if we look at 4 and 20, we would just do the same thing that we did above for 12 and 18, and we would say, okay, 1 and 4, 2 and 2, okay, and so that list is done. So we've got 1, 2, 4, 1 and 20, 2 and 10, 3 doesn't work, 4 and 5, and then we're already at 5, so our list there is done. So we've got 1, 2, 4, 5, 10, 20. So the numerical highest common factor is going to be 4. And it's very possible that you could do that, figure out that it was 4 without doing all of this. And that's completely fine. I'm showing you a method. If you're not sure what the numerical component is, you can do this method. So numerically, the numerical component of the highest common factor is going to be 4. And then we need to address the variable component, the alphabetical component. So x squared is equal to x times x. And then the alphabetical component of our second term is xy, which is x times y. So what you need to do is identify in the alphabetical component, in the variable component, what letters are in both terms, or presumably in all terms if you have more than 2 terms that you're dealing with. And the only thing that appears in both lists is a single x. So that becomes the alphabetical component of the highest common factor. So our highest common factor here of 4x squared and 20xy is going to be 4x. Numerical component, alphabetical component. It's possible that you may have a question that doesn't have a numerical component, or the only numerical component it has is 1. Or it may not have an alphabetical component, and that's fine. Every situation is going to be slightly different, but you need to check both the numbers and the letters to ensure that you get the highest common factor. Okay, we're going to look at one more example, and at first glance, this one is going to look a little more complicated because it has brackets. This one is actually easier than the other ones. So when you're dealing with terms that have brackets as part of them, you need to check for any coefficients, any numbers or letters or any terms at all that are outside the brackets. Do both of the terms have any numbers or letters outside in common? And the answer is no, because this one doesn't have anything outside of brackets. So this 3 is not going to be part of our highest common factor. And then you need to look at the bracketed components. Do you have any brackets that are exactly the same? And the case here is yes, we absolutely do. We have an x plus 1 in a bracket here. We have an x plus 1 in a bracket here. So those two components are exactly the same. So the highest common factor of this, there is no component outside of the brackets, so the only thing we have for highest common factor is this one bracketed piece that is in common, that is common to both of those terms. So that's going to be our highest common factor of those two. I hope that's been helpful. Do your best. Off you go.